Question 3. The variables y and x are related by an equation in the form y is equal to a times bx, where a and b are positive constants. We're going to let y equal log y, and we want to show that there is a linear relationship between our big Y and our little x. So first of all, if we take this equation here, and what we're going to do is we're going to log both sides of this equation. Okay, so we're going to use a log of base 10. So that means I'm going to have a log with base 10. So this is part A over here. Log of base 10 of y is equal to a log of base 10 of a bx. A b to the power of x. Now, using our log laws, we should be able to split this because this is the product of two terms here. So I can change this to, well, that tells me that log 10y is equal to the log of a plus the log of b to the power of x. So further to this now, using my log laws again, I know that this is going to be equal to x log b. I'll just put the base number in there, so that should be base 10. So I can rewrite this as log of y is equal to the log of a plus x times the log of b. Now, we're going to let y equal the log of y. So I can write this in as y is equal to the log of a plus x times the log of b. Okay, and we've now shown that this is a linear relationship because the log of a is a constant value, because we know that a is constant, so the log of a is constant. So this would be, if we had our equation in the form y equals mx plus c, that would be our c value or our y-intercept. The x is just going to be x, and the log of b is our coefficient of x, so this is like our m value, our gradient. So log b is going to tell us our is going to be given to us, by our gradient. So if we move on to part b now, we should see that, okay, so the graph of y against x, so capital Y against x, is shown, and it passes through the point 0, 2.5 and 5, 0.5. So my c value is going to be equal to 2.5. So this is if I had it in the form y equals mx plus c. And my m value, and that's going to be the gradient of this line. So that's the change in y divided by the change in x. So my change in y here is gone from 2.5 to 0.5. So my change in y is -2. And my change in x is going to be, well, it's gone from 0 to 5. So it's going to be 5. So my m value here is going to be a -0.4. So my c value is 2.5 and my m value is a -0.4. Okay, so for the first part of b, I need to find the gradient of the line. So that's this bit here. I've done that already. I found the gradient of the line. For the second part here, I need to find the values of a and b giving each answer to 3 significant figures. So for part 2 here, well, because I know that c is equal to 2.5, and from here, this here is telling me my c value, so my y-intercept value. So I can say that log of a must be equal to 2.5. Yeah, so that's my y-intercept here is the same as log of A. So to work out what A is now, I need to do 10 to the power of 2.5. So I'm anti-logging this, if you like to call it that. And I'm going to do 10 to the power of 2.5. And 10 to the power of 2.5 is going to be, to three significant figures, 316. Okay, so my I'm going to come over here. So my m value is negative 0.4, and that's given by this log b over here. That's going to be my gradient, so I can say that log b is going to be equal to negative 0.4. So that tells me that b is going to be equal to 10 to the power of negative 0.4, and that's going to be equal to and to three significant figures it's going to be 0.398. Okay, and that's it. So we've worked out the value of A and B. Okay, thanks very much for joining me. I'll see you next time.